Assalamu alaikum. Hey guys, if you would like to create this kind of nice looking animation from raster imagery, please watch this video till the end. I will explain every bit of code line by line in Jupyter Notebook. So without further delay, let's just jump into our tutorial. Okay, so to create that kind of animation, I have come to Jupyter Notebook where I have written all of my codes in Python already, and from these codes I will make you understand how to generate that kind of animation. So I will definitely explain each and every line of code section by section. So for this tutorial I need to use a satellite data, a raster data, which I'm gonna use from Lancet image, which I have stored in this particular folder. So here you can see that these are the Tiff file, which is nothing but the single band images extracted from Lancet. So these are 20-year images from 2002 to 2021, and it demonstrates how inundation changes from time to time and space to space. And if I just show you in zoom form, look, these are all raster images and it is panchromatic or single band image. So I'm gonna use this images to create a nice looking animation that I have shown you at the first glance of my tutorial. So let's come back to Jupyter Notebook and start uh, explaining the lines of codes that I have written for this tutorial. So first of all, for this tutorial, to make the animation, I need to import. First of all, if you don't have uh, those packages installed yet, please install using pip or conda environment. I have already installed all those packages. Now I need to import it. So my first section of code is nothing but about importing necessary libraries. So what are those? So let me just come back to code. Here I have imported OS, that means operation system libraries, Imageio library, which deals with images. So it reads through the image property. That's why I need to import image. And I also need to import NumPy to create a NumPy array from the list, which I have here. And I just use pandas. This is optional. So either you can import it. If you can't, that's okay. But this is not mandatory. So the mandatory libraries which are required to import is matplotlib, Imageio, and the other one is Rasterio. Rasterio is a library which deals with raster images. And apart from these three or four, major library, there are also some nested packages which you also need to import to complete this tutorial and to get the desired results. For example, matplotlib.pyplot as plt. As alias, I have plt, and matplotlib pyplot as mplt matplot, and so on. So as you can see that I have imported all these essential libraries required to finish up this tutorial. So let's just run this part of code to import. So it is imported, the code runs, so it means all these packages are available to use in this coding environment. Now the second section of my code is dealing with dragging the input data, satellite data from input directory and creating the output directories where I would like to store the animation file. So here let's call it rather dragging input, that would be dragging input data and creating output directories. That makes sense. So let's try to run this piece of code here. So if I run this code, there should be a new directory, a new file in the same directory called animation wet. So let's first run this piece of code. So it is successfully run, and we can check that whether this directory has created an animation file, an animation underscore wet file or not. So let's check it. Here, look, this is the animation wet which was created by this piece of code, because earlier there was no file called animation. So we have successfully run two sections of our code. We have imported all the libraries. We have dragged the input raster data from our desired directory, and we have also created the output directory called animation wet, where we are intending to preserve our output data. Now, creating PNG from Tiff images. This part of code is essential to understand. So let's go ahead and come back to coding interface. So look, I have added the comments to almost each line of this section of code to make you understand uh, what does this line mean and what is the function of this line to perform in our code. So first I declare a variable called file list which contains a list. So in this list we have used the for loop and also the conditional if conditional to search any raster file which has been stored as Tiff file. So I have added the comment search for Tiff files in the current directory. After that, we have again declared we have again used the for loop in file list, which is this file list, where we have performed two kind of things. One is opening the inundation raster, which is this variable inundation raster file using Rasterio library, which we have imported here. Once we have opened this raster file, we are ready to read it. Then we rename this variable called inundation raster. So we have opened the raster file. We have also access to it to read it. Now I have to define the color. to demonstrate, to display the animation, how it changes from uh, time to time and space to space, because the raster file has been stored in Tiff format, and it shows the inundation variation or changes from 2002 to 2021. That means the temporal change or temporal variation, and it also can demonstrate how it has been changed from space to space. That means spatial variation. It can also give us information. So if we have this kind of color which will demonstrate the inundation, and the other one will demonstrate the non-inundation, that would be very nice to look at. So as I mean, my raster images, look, these are the single band or panchromatic image, and the image contains the binary value 0 and 1. So 1 for inundation and 0 for non-inundation. So we need, that means, two color to represents either inundation or non-inundation. That's why we need to specify a color band for one condition and for the other condition. So let's just set the color for color map, setting the primary color to display inundation extent, and these are the reverse color which will demonstrate the non-inundation, which is not inundated. So here we have just determined the figure size, what should be the figure size, length and width. And here this line of code is very, very important to understand. We have this inundation raster, the access we had due to use Rasterio library, and we have some parameters as we are using Imageio function. So inside the parameter of Imageio function, we need to import or call upon the raster images, which is this one, and determine the color, which color we should demonstrate for inundation or non-inundation color map. And this is the visualization mean and visualization max. So all of our images have two kind of binary value. I mean, the pixel are classified either in 0 or 1. So that means the visualization mean is 0 and the max is 1. So that's why I have written importing raster with mean and max value to visualize. Now we have this function called split function, because in our file, if you go to here, this is the underscore. So using this underscore characteristics, we can split this file format. So splitting file format by underscore within, and then we have just customize, removing 4 characteristics in the file name. Now we're gonna print this raster file into PNG format, and that's why we are just clarifying the format using the format function. And these are all the ornamental part of your image. what would be the title, and what would be the font size, etc. So this is just, I mean, some basic like ornamental or decorative part of your images. Here, getting current exists. Like I have used the I mean GCA, getting current exists function. So for the image, we don't need the edges. That's why, first of all, getting the current edges, which are automatically default to the images, and then we remove this x-axis and y-axis using this get x-axis and y-axis function. Now we have used the color bar, plotting the color and adjusting the subplot parameters. Color plot, which will range the value of pixel from inundation to non-inundation 0 to 1. And this is the label of the color bar. Let's call it time series inundation. This is the size. This is nothing but all of the ornamental part. Now here we have used the tight layout function to controlling the extra padding. Like if you were familiar with HTML or CSS, this part is more interesting to you. It just, I mean, controls the padding of your image. And here we're gonna save this images as PNG. And here we have specified DPI. If you wanna put or post this animation into any social media like or LinkedIn, then just, I mean, keep it in 200 DPI. That's fine. And now I have given the command called close so that, because I have 20 years images, so once we have 20 years images, I call this function to close. So now let's try to run this part of code as you understood, I assume. So let's run it. Look, it started running and giving the output like the PNG image of 2002, 2003, 4, 5 until 2021. So all this image should be preserved in the newly created file called folder called animation wet. So now let's go back and check that folder whether it has those PNG file format. Look, these all are PNG file. These all raster file are stored in PNG format, and which are just right now created. So now we have this PNG format raster file, and we are just left with this last part of code to create the animation. So let's come back to the coding part. So here we're gonna declare a function called make GIF, and here we have these two parameters inserted into the function called input folder and save file path. So here episode frames, we have declared a new empty list which we will be using to convert it to an array, numpy array here. And here is the time per step, which is the period length to animate each raster. So you can just change it. This is in seconds, so 0.30 second. The less it is, the speeder the animation. So Here we have this another for loop to connect the input folder where our data has been, these are the data uh, which is the latest modified, which will connect by this for loop. And here we have defined the file paths. This is the list, and then we have just sorted the file path using the lambda function. And here episode frames, this was a list. However, using the numpy array, we have converted this list into a numpy array. So here I have the comment filling the list with raster and reading the image, this one, and converting list to a numpy array. So subsequently, look, episode frame, first we had this empty list. Now we have filled this list with images and like other parameters record. Once we have this list filled with images or data, we can convert this list into a numpy array using np.array function. Now we have this Imageio function, Imageio dot memsave function, which just turn the PNG to GIF, because eventually we need a GIF format raster file to create the animation, and that is done using Imageio.memsave function. And finally, the rule of making a function, you know that once you made a function, at the end you need to call that function to execute. So we had this function. Right now we are done almost, so we're gonna call this function make gif to execute, to calling back the gif function to create the animation. And once it is done, we just give a command by using print function raster animation done. So if this function is executed, please print raster animation done. That means raster is done. So let's try to run this last piece of function and see. Look, raster animation done. That means the last section of our code has been done, and this statement raster animation done proves that. So now we should look for this final animation a file called animation rainfall wet .gif file, which contains all this 20 years inundation data, and it will be amalgamated, combined to demonstrate the inundation condition in GIF format. So let's go back to the file and try to look for the animation.gif file. So look here, this is the animation file called animation rainfall wet, and it is found in GIF format. So how could you understand that? I mean, this is the animation, very easy to differentiate. Look, all these prior raster file are in PNG, however the only one is in GIF file, which means that this should be the animation. So if we go ahead and try to open this animation, look, this is the exactly animation raster file which I had shown you at the very beginning of my tutorial. So look how it changes from time to time, and it also shows the corresponding year, which year has the highest and lowest inundation extent, and also which place has the lowest or highest inundation extent. So at a glance you can just have a look, and this is a nice representation of animation, I would say. So that's all for the time being. I hope you guys have liked my video. If you have, please do subscribe to my channel. I will come up with another new video. Till then, bye bye. Allah Hafiz.